Algebra 2, Lesson 7-5, Exponential and Logarithmic Equations. Our objective in this lesson is to be able to solve equations using exponential and logarithmic properties. Okay, well let's get going. Alright, first we're going to look at some exponential equations. And just so you know, exponential equations are those which include a variable in the exponent. It's not that they have an exponent in the whole equation. That variable has to be in the exponent. So here's a good example of it. And there's really two different kinds. We're going to talk about the ones that have what we call the same base and the ones that have different bases. So first let's look at the ones with the same base. Now it doesn't look like it has the same base, but we have 27 to the 3x equals 81. But if you look at it for a minute, you realize that 3 to the third power is 27. So I'm going to kind of write that over here. Let me get a better color. 27 equals 3 to the third power. I'm hoping you can see that one. It's kind of light. Okay? And 81, well, 27 times 3 is 81. So let me write that over again. 27 equals 3 to the third power. And 81 equals 3 to the fourth power. So I can change those to 3 to the third power to the 3x equals 81 to the, or whoops, sorry about that, 3 to the fourth power. Okay? Just substituting these in for those numbers. Now, if you remember your property of exponents, when I have an exponent raised to an exponent, I can just multiply. So I have 3, and 3 times 3 is 9x, 3 to the 9x equals 3 to the fourth power. And as long as you have the same base, you know that this value, let me get another color, this value right here has to be the same. So 9x must equal 4. 9x equals 4. And we can, from there, solve for x. And I have x equals 4/9. And that is the answer to that question. Okay? And that is when you have the same base. So when you can figure out that there is a base that they have in common, you can figure it out that way, using your exponent properties. But honestly, most numbers don't have the same base. So more often you will be faced with something like this, an exponential equation with different bases. And here we have 5 to the 2x equals 130. So we cannot change it to the same base this time. So what do we do? Well, we have also learned about logarithms in this chapter and their properties. And we've even made our little sheet with all the properties of logarithms. So what I'm going to do in this first is I'm going to use this and change it into its logarithmic form. So I'm going to put that right there. And remember that if I have, this is kind of that b to the x equals, b to the y equals x thing here. So I'm going to do log base 5 of 130 equals my exponent 2x. Okay. Log base 5 of 130 equals 2x. So what do we do now? Well, let's get x by itself. X by itself, we divide by both sides by 2. So I have 1/2 of the log base 5 of 130 equals x. So now I just need to figure out what the log base 5 of 130 is. And if you remember, we can do that with a calculator by using the change of base formula. Remember that one from the last lesson. So we're going to change it into a common log because that's what we can put in our calculator. So we have, let's turn this around for just a minute. We have x equals 1/2 the log base 5 of 130. So I'm going to say the log of 130, just the plain old common log of 130, over the log of 5. That's using my change of base formula. And I'm also going to still have to take that all times 1/2. Okay, so that's what I'm going to put in my calculator or find out on my table. The log of 130, here's the calculator for this one, 130, and put in log, is 2.114. I'm going to round to the nearest thousand. The log of 5, whoops, turned it off, 5, is 0.6, well, actually, if I round, it's actually closer to 0.700. Okay. And still I'm going to take all of this times 1/2, or 0.5. Okay, so I have 2.114 divided by 0.7 times 0.5 equals 1. And remember, we really should put approximately, not equals. Bad, Mrs. McLemore. 1.51. Oh, it's even. Okay, so that is my answer to exponential equations with different bases. Change it to the log. We almost should write that. Change to the log and use the change of base formula to find the value. Okay, that is solving exponential equations. And then the next part, we'll talk about logarithmic equations.